Welcome. We will focus on IQRF technology, which is a technology for wireless mesh networks, and today we will be particularly interested in its ability to save energy, because battery life is a major challenge for IoT devices. So how does IQRF achieve such low power consumption, and how are the sensors able to function for years? I think it is important to be able to predict what that consumption will be.
Yes, I would say that's a big difference compared to some other technologies. Those sometimes work a bit like a black box, but IQRF clearly states the consumption parameters for different modes, so we know what to expect. And that's really crucial for system design.
Okay, let's take a closer look at the savings strategy. The transmission itself is very short, so its impact on consumption depends mainly on the set power, right? But what about receiving? That's often the biggest energy guzzler.
Exactly. And it's precisely the optimization of reception that is one of the pillars of savings with IQRF. There are various variants of the reception mode. For example, STD or LP. The differences are significant. So choosing the right mode has a huge impact on battery life. And then there's another layer of savings with sleep modes. In sleep mode, consumption is less than 1 microamp. And in deep sleep mode, consumption is less than 100 nanoamps.
100 nanoamperes, that's almost nothing. To put it into perspective, that's less energy than some batteries lose just by self-discharging when they're just sitting on a shelf, right?
That's exactly the idea. It's almost as if the device is completely turned off, but it's still ready to wake up at any time. This is nicely illustrated by the example of a standard half AA battery. Theoretically, it would last 1,000 years in deep sleep mode.
Okay, that's just to give an idea of the limits.
But what if the device does not need to be active all the time, which is probably the case for most sensors, right? Devices can operate in what is known as beaming mode. This allows for even greater savings.
The principle of beaming is actually ingeniously simple. The transceiver, the wireless module, spends most of its time in sleep mode, with the minimal power consumption we talked about, and wakes up only for a very short period, say once an hour, at which point it asynchronously sends data to the nearest devices in the network, which act as aggregating repeaters, and then goes back to sleep. The repeaters temporarily store the data, and the central element of the network, the coordinator, can then collect it at regular intervals as part of planned synchronous communications in the network.
So the device communicates without having to be constantly on alert and listening.
The devices are actually completely offline most of the time, and only occasionally, briefly, as you say, simply shout their data into the ether. This saves a huge amount of energy.
As a result, sensors can easily operate for decades on a single battery. Thanks to beaming, it is now possible to deploy indoor environment quality sensors that measure temperature, humidity, CO2, gas concentrations, or even the status of flood sensors, and simply let them operate for years without a single intervention.
An example is the IQAROS sensor set. It is made by the Czech company MICRORISC. The manufacturer estimates a theoretical battery life of over 20 years under normal operation and even guarantees at least 7 years of operation without battery replacement for industrial sensors.
And all thanks to beaming. Imagine huge buildings, industrial sites, or even monitoring bridge structures for years without having to climb up to the sensors to change the batteries. That's a big deal.
So let's summarize. The magic of IQRF does not lie in a single trick, but in a well-thought-out strategy. From energy-saving reception modes through extremely deep sleep to the innovative beaming method, which actually allows devices to operate at minimum energy consumption most of the time. And the result is the potential for decades of battery operation. Is that right?
Exactly. And I think that brings us to an interesting question, something to think about. So, if we have technology with such extreme energy efficiency and longevity, what completely new possibilities for monitoring or data collection does that actually open up? Things that were simply unimaginable before because of the power supply. We can probably think about massive deployment in smart cities, maybe even in long-term personal health monitoring. Where else could sensors be useful and they then actually work and send data for years without any worries?
Yes, that's definitely a question worth thinking about. Thank you for listening, and don't forget to stay tuned for the next episode of our podcasts.